Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So let's get started. So we have a medium today. It's called minimum operations to make a Uni-Value grid. So let's see what that means. So given a grid, it has size m times n, which is okay. So like the maximum amount of elements we can get is 10 to the power 5. Let's also find out what x is. So x is an integer from 1 to 10,000, and so does every single like grid value. So here's the definition of a Uni-Value grid. So it is a grid where all the elements of it are equal. Right. So we want to return the minimum number of operations to make the grid Uni-Value. And if it is not possible, we want to return -1. Oh wait, we also have this. So in one operation, you can add x to or subtract x from any element. How much are we allowed to do this though? That's the question. Right, so we can do. Wait. A Uni-Value grid is a grid where all of the elements are equal. Okay, so we actually want the minimum number of operations to make the grid Uni-Value. Right. So I guess we should first check. So because like right now, what we can do is, so let's say for like the third example, right? We have 1, 2, 3, 4, and our x is 2. That means like we can turn any number into something like this, right? So that means the first thing we have to check is whether it is possible to actually like make the grid Uni-Value, right? Well, but obviously for the third example it doesn't work. Well, because like this, so x is 2, right? So this is always going to be odd. This is always going to be even. So what does that tell us? So the first observation that I can make is that we have to like check the modulo. Oh, so we have to check like all the grid values modulo x, and we have to make sure that they're all equal first, before we actually find the minimum operations. And the second thing we have to do, we want to find the kind of like the middle value, right? So let's like if we are looking at like 2, 4, 6, 8, well, the middle value is gonna be like either 4 or 6, right? It is always better to to have the numbers going to the middle value, right? Because like let's say we want to turn everything into a 2, then 8 is going to take like 3 steps, 6 is going to take like 2 steps. But if we move like 1 forward, well, like we can reduce like 2 steps here, and then we're only adding like 1 step like from the left, right? Yeah, so the question now is, do we want the median or the average? I think average is always, it should be a bit safer, I think. Is that true though? So here, well, we can make every element equal to 3. I guess the other thing we can do is so let's say we flatten this this grid. Well, because like we don't actually have to think about it as a grid. We can think about it as an array of numbers, right? Like like it just has to be Uni-Value. So it just means that all the elements have to be the same. Maybe instead of finding like the average or median, well, maybe one of them works, but I couldn't think of a proof straight away. So the next best thing is if we just do a linear sweep. So we first get the number of operations. If we turn all the numbers into 2. Oh wait. What if we have something like 1 to 99 and 100? Do we want to turn it? Well, actually, what are the values? Well, the values are not that big. So, what if we turn it? Yeah. So, let's say x is like 1 in this case. If we do 50, or like, how do I say this? Okay. So what I was trying to do up here is we just want to check like turning each number just trying like each of these number and turning all the other numbers to that number and check whether that works, right? But what if we have like something like 1 to 99 and 100? Maybe I can like make it a bit smaller, and then x is equal to 1. So intuitively, turning everything to 3 is the best, right? Because like we can do 2, 3, so that would be 1 step, 2 steps, 1 step, and 2 steps. But what if we move it to like either 2 or 4? Would that not be optimal anymore? That's the question, right? Yeah, I guess like if you do 1 and 2, so if you do 2, so you don't need to do anything here. You need to do 1 step here, and then you have to do 2 steps and 3 steps. So yeah, we do actually want 3, so we can't just check all the elements. Well, the other thing we can do is we can check because the grid values are only like up to 10,000, right? So technically, if x is equal to 1, we can just check the minimum. Wait, not for x, for like each of the possible values. So that would be like 1 to 10,000, and well, that would be like well within time limit, right? Yeah, except we don't want to go through every element. We want to find some quicker way to determine how many operations for each of these values. Yeah. If we do it in this case, we also have to account for the like the x value. So like if x is equal to 2, we cannot like if x is equal to 2, and let's say everything mod 2 is 0 for the grid, so something like example 1, we can't like it is invalid to check like what like the minimum operations for like x is equal to 3, right? Because it's just not possible. But I guess we can still do the same loop. Yeah, but if we have that in mind, what can we do here? So I guess we can have a. Is there an easier way of doing this though? And also, like intuitively, using average would work, because well, it gives you the middle value, and that should be the best. But yeah, I'm just not sure if that's actually true. Like, let's say, what if we have like 1, 99, and 100? So what would be the average here? So it would be like 200. So the average should be like 66, like, or 67, right? Uh, let's turn down the number a bit and maybe make it a bit nicer. So it actually divide um by so it actually divides by like 3. So the average is going to be 7 in this case, right? But is that the best, or um is moving it all the way up to 10 the best here? So if it is 7, let's say x is like 1, that means we have to do 6 operations on 1, and we have to do 3 each here. So that would be like 12 operations. But if we set it as 10, we only have to do 9 operations, and then so maybe we do want the median. Maybe we do want the median. Well, obviously this, like, checking for every single value works, but it is annoying to code it out. That's why I'm going back to the median solution, and hopefully that works. Yeah, but when we have something like this, so our median is going to be like 2 and 4, right? And so I think, like, maybe by then we do want to, like, take the average of that. Yeah, because, like, so there are 2 possibilities. Yeah, I think, like, if we think about the number of elements, it will make a bit more sense, maybe. So let's say we have like an odd number of elements, and then we have the median here. So what this means is, if we make if we turn every number here, what that means, like, every time you shift over, like, either way. So let's say we're shifting it to the right, we are taking less operations on this side, but then for all of these we are taking more operations. And wait, and that's actually constant. So let's say we have like A1, A2. Why is my pen not working? There we go. Yeah, actually median should work. Because, like, if we have this, so we have like some operations, right? But if we move over, let's say, like, to n plus 1 or something, well, n plus x, whatever x is, we need one more operations on this side, right? But then, like, on this side, if n plus x is still like somewhere in between, well, that's fine. Like, we will just get rid of 2 operations on that side. But if n plus x is like over here, right? So we are introducing another element. That means, like, we are increasing, well, like 3. um well, let's say maybe like 2, maybe 2x makes more sense. But, like, I'm just saying, like, if we're moving, like, the Uni-Value over, and we actually include more elements, then, like, we're gonna have to do more operations here, and the number of the number of values that does less operations is going to decrease, and the same thing for that way. But we also have to see what happens. Yeah, if these are the median values, right? So something like 1, 2, 4, 5. So we can see that, like, taking 3 here is the best. But the question is, what happens? I don't know, if you have like 1, 2. I guess because we check, like, the modulo of every number, it doesn't quite make sense to yeah, we always have a clean average in the middle because, well, if you think about it, uh, like we have some remainder, it's going to plus like kx. So all the elements are like this, right? Where r is the same. K could be different though. Um, but let's say we have like r plus k1x and r plus k2x as the median, like the two middle values, when we have even number of values, um, we can always have like a middle. Wait, actually, that's not true. But I think it shouldn't matter because we are moving it in such a case where like so so my point is like the average would be like k plus one something like this, right? So like k1 plus k2 divided by 2x. But what if this is odd? So we're gonna get like some like bad middle number in there, right? Um, but actually it is fine because so we can either round down or round up. Um, but if we use this value, oh, I'm pretty sure I've gotten out of frame. So that's the formula, right? Like for the average of the two like middle number. Um, so if this is odd, wait, if k1 plus k2 is odd, that means it would be like something 0.5, right? So if you round down, round up, well, it doesn't really matter because when we go from like the lower value to the upper value, um, well, all of the left hand side elements is going to take one more operations, but all of the right hand side elements are going to take one less. And because our array is even, if we have two middle points, well, that's exactly the same, right? So yeah, actually median would work in this case. Um, yeah, sorry for the very long proof. But yeah, I like proving that my algorithm works before writing it out. For I don't know. It just feels better, I think. But yeah, we can code this out now. So so the first thing we want to do, check if all elements mod x is equal. So we have the remainder. Well, we can just get the first element. Let's see. Yeah, so we have at least one element, so we don't have to check for that case. So we just get like the first element and we mod x, and now for I in range, length of grid, we can make some constant actually. So row and column, length grid 0. So that will be row, and then for j in range column. So if grid ij, mod x is not equal to the remainder of the first element, that means we have like two conflicting elements, right? And it just wouldn't work. But once we get out of here, we know that we can turn grid into Uni-Value, grid here from this point on. Yeah. So now I think what we want to do is we want a sorted elements. I'll use list comprehension because it's more Pythonic. So it will be, I think something. So like, element for row in grid for elements in row. I think that's how you do it. And then, of course, we want to sort it. So now, well, if we have, so we have the odd case, and we have the even case. I guess for both, we can like, we can solve for the median. So, so what we want to do is if row, so if the total number of elements, wait, do we get that? Yeah, we don't actually get that value, so we'll just do that. So if it is, if mod 2, just make it more clear maybe. So we can do that. So that's the odd case, right? Also, I'm gonna put this here. And then, of course, we have else, which is going to be the even case. So we have median is equal to the middle value, right? So that's going to be the length of sorted nums, sorted elements, divided by 2. Is that true? So let's say we have 3 elements. So the length is going to be 3 divided by 2. That's 1, which is the median. Yeah, so that should work. Otherwise, we are going to have sorted elements. So let's say we have 4 elements. If we divide it by 2, that's going to be 2. So that's going to give us the second middle point. So if we want the left middle point, we have to do this. And then, of course, we add the right element, and then we can just divide it by 2. And as I said before, it's fine using like the rounded down or the rounded up average between the 2 elements. So it'll work. And then now for sorted for element in sorted elements, so we want minimum operations. We want to get the count for that. So minimum operations. What we want to add is, wait a second. What if we get like 4 and 6 actually? That's going to give us 5, which is not what we want, right? Yeah, we actually want the closest one then, right? So we actually have to do a bit more here. What did I say here before? Yeah, so if k1 plus k2 divided by 2x, if it is smaller, wait, should we do like the remainder? This even case is actually pretty annoying to deal with. Yeah, so we want this. What if we just use this formula actually? So we want the remainder, which we have gotten before. So remainder is going to be rem plus. So we want k1 plus k2 divided by 2. So how do we get that? So if this is the number, so if this is the left number, right? I think we can just do, like, we can just divide it by x, like cleanly to get k1. So we can just do this divided by x. And then we can do this also divided by x. So that will give us k1 plus k2. And then we want to divide that by 2 and then times x. I think that would be the number that we actually want. So plus x, sorry about that. So we can just get wait, so the median is going to be like 4, right? So we want the difference between the median and our number. We actually want the absolute value of that. So you get the difference, and then well, we just divide it by x to get the number of operations we need to move, well, like to turn element into our median. So you can just do that, and then we can just return minimum operations. If it is wrong, it will be this line. Yeah, what did I do wrong? So x is 73 in this case. Yeah, what would the median be in this case? Let's print it out. Yeah, either my algorithm is wrong, or maybe I've like maybe I calculated this thing wrong here. So yeah, why is our median so low when all the numbers are so high up? So that's definitely the issue that we are facing. Yeah. Actually. Yeah, what is wrong here? Oh. Should be times, right? How did I miss that? And how did I pass so many cases having this thing wrong? What? Yeah, again, my algorithm should be correct, but instead of like multiplying by x here, I did plus x. Just silly mistakes. But yeah, I actually quite like this problem. Well, it is a bit tedious to like find the answer, I guess, or like figure like proving that the median actually works. But yeah, it's quite mathy, which is like kind of my kind of questions. I like mathy questions, like finding the formula, and like if you look at this, the code is very like clean and easy. Yeah, so yeah, that's it for today. If you have any questions you want me to do, just leave a comment below, or any feedback, please comment as well. And yeah, thanks for watching, and I'll see you tomorrow. Bye.